Linear equations in two variables. Using slope. We'll begin our study of linear equations by taking a look at the slope of a non-vertical line. And the slope is simply the ratio of the number of units a line rises or falls vertically to the number of units of movement right or left. Quite often when you begin learning about slope, you'll learn about it as rise over run. If you're a little fancier, delta y over delta x, as again, we're just looking at the change in y over the change in x as a ratio. For example, if we know that a line passes through the origin, which is right here at 0, 0, we can use slope to find other points on our line. Here, if our slope is 2/3, that means the rise over run is 2 over 3. So from 0, 0, I would rise 2 and run 3, both in the positive direction. And then I could do that again from my new point, rise 2, run 3. And you can see the line is becoming very clear. Keep in mind that equivalent to 2/3 is -2 over -3. So I could also rise -2, which means, of course, go down 2, and then run -3. And we can see that, again, by doing negative and negative, I'm getting a point on the same line. And that's how I can construct my line that goes through the point 0, 0 with a slope of 2/3. One of the most helpful forms of linear equations is the slope-intercept form of a line. And that is given by y equals mx plus b, where m is the slope that we just talked about. M is rise over run. And b is, of course, since it's called slope-intercept form, b is going to be the y coordinate of the y-intercept. So if you would like, you can write that as 0, b. For instance, if I wanted to graph the line given by y equals 5x minus 2, I would start at the y-intercept. So I would start at b. b in this case is -2, and that means my very first point would be at -2 on the y-axis, or of course you could write that as 0, -2. Then I would use the slope. In this case, the slope is 5. So if I put that to my rise over run, that's 5 over 1, because 5 is the same as 5 over 1. So I can do a rise of 5. So 1, 2, 3, 4, 5, and a run of 1. And I could do that again, 1, 2, 3, 4, 5. I'm off my graph, but it would be somewhere up here. Or just as I did last time, that's the same as -5 over -1. So 1, 2, 3, 4, 5, and to the left 1. And I can see that this is now the graph of my equation. Many students do a great job using slope-intercept form to graph a line. However, they get a little confused when dealing with horizontal and vertical lines. For instance, a horizontal line is in the form y equals b. And I wanted to start with that one because this one actually makes sense in terms of our slope-intercept form. Our slope-intercept form says y equals mx plus b. Well, in this case, m is 0. And that just gives us the result of y equals b. So if I have something that is in the form y equals b, like y equals 2, it simply means it's going through the point 0, 2, and it is a horizontal line. You can always check your work here. This is obviously the point 0, 2, but I can also look at other points. This point is the point 4, 2. Notice y is equal to 2. This is the point -5, 2, which of course has a y value of 2. The one that doesn't work with slope-intercept form is the vertical line. And a vertical line is in the form x equals a, where a is some constant. And the reason it doesn't work is because in this case, vertical lines have an undefined slope. So that means the rise over run is some number divided by 0. And we all know we can't divide by 0, and that's why this is called undefined. So whenever you get an undefined slope, you know that you're dealing with a vertical line. For instance, x equals -3 would go through any point where x is -3. So here the point is -3, 0, so the x value is -3. Here the value is -3, 5. Again, x is -3. Here the value is -4, -3, -4. And again, the x value is -3. Because slope-intercept form is so helpful, it's often nice to be able to turn other standard form equations into slope-intercept form. And a standard form equation is simply written as ax plus by is equal to c. So x and y have a degree of 1, so this would not be standard form linear if I had a degree other than 1 on x or y. So it's going to be some number times x to the first plus some number times y to the first is equal to some constant. And in order to write this in slope-intercept form, I'm going to start by moving the x value to the opposite side. So on my first example, I'll subtract 4x from each side, and that leaves me with -y is equal to, and I could write 10 minus 4x, but because I want to write it into slope-intercept form, which is y equals mx plus b, I'm going to write it as -y is equal to -4x plus 10, because again that 10 is positive. Now I'm almost where I want to be, but I have a -y, so I have to divide everything by -1 because I want that to be positive y, and that will give me a positive 4x and a -10 or -10. So now I have rewritten a standard form equation into slope-intercept form. If you're feeling up to it, go ahead and try the second one. If not, I'm going to go ahead and get started. Again, I'm going to start by subtracting the x from each side. That would leave me with -4y is equal to -x, and again that's a positive one, so plus 1. In this case, I don't want to divide by -1 like I did last time. I need to divide by -4. So if I divide everything by -4, that's going to leave me with positive y. And here, again, it's not a bad idea to put a 1 in front of that x, because now I have a -1 over -4, or positive 1/4 x. And then I have positive 1 divided by -4, so minus 1/4. I have some practice for you here I'd like you to try on your own first. So if you would, pause this video and take a look at the 4 linear equations that I've asked you to graph. Go ahead and graph them and then press play to see how you did. I'm going to start with y equals -2x minus 3. This one is already in the correct format, so I'm going to start at -3 on the y-axis, or at the point 0, -3, if that helps you to feel better. And my slope is -2. I'm going to rewrite that as -2 over 1. So that means I'm going down 2, but the 1 is positive, so I'm going to the right one. Down 2 to the right one. Just as we did before, when we did rise over run, I can think about this as 2 over -1. So I can go up 2 and to the left 1, and you can see that those points are on the same line. So that's my first graph of the line. For my second, I have y equals 1/5 x. I'm going to say that's plus 0. So even though it doesn't show plus 0, that is where my first point will be, is at the origin, or at the point 0, 0. I'm using a slope of 1/5, so a rise of 1 to a run of 5. Or just as I did before, I can think about negatives, down 1 into the left 5, and now I've got my second graph. For my third, I have y equals 3. Remember, this is either going to be horizontal or vertical because there's just one variable. This one is the easier one. It's y equals 0x plus 3, so it goes through at positive 3. And the slope is 0, and a 0 slope has no rise. For the last, I have 2x minus 4y equals 5. This is not in the correct format, so I'm going to start by subtracting 2x from each side to give me negative 4y. That was a horrible 4, and I apologize. Is equal to negative 2x plus 5. Then I'm going to divide everything by negative 4. That gives me positive y is equal to negative 2 divided by negative 4 reduces to positive 1/2 x, and then minus, because I have 5 and negative 4, so I've got minus 5/4. So you might be saying, how am I going to graph that? Well, negative 5/4 is negative 1 1/4. So I'm going to go to negative 1 and go about 1/4 more than that. And then I'm going to use a slope of up 1 over 2. And up 1 over 2. And connect the dots. Finding slope of a line. We know how to use the slope to find additional points on a line. Let's take a look at how to compute the slope given 2 points. We have the equation for slope, which is a non-vertical line that passes through 2 points, x1, y1, and x2, y2. And we're still using rise over run, or the change in y over the change in x. And all we're going to do is subtract the y values in our 2 points to find the change in y, and subtract the x values in our 2 points, our 2 coordinates, to find the change in x. For instance, let's take a look at negative 5, 2 and 7, negative 3. As you first begin to find slope, it's not a bad idea to label the first point x1, y1 and the second point x2, y2. It's not necessary, but if you are doing this for the first time, it might help you to stay organized. To find the slope, I'm going to take the second y value and I'm going to subtract the first y value. Then I'm going to find the second x value and subtract the first x value. So my slope here would be negative 3 minus 2. If you'd like to flip, change, that gives me negative 3 plus negative 2, or negative 5. For the denominator, 7 minus negative 5. Again, when you're subtracting, you can always flip, change, KFC, which always makes me want to eat chicken. And I have 7 plus 5, which is 12. So my final slope is negative 5/12. You'll find yourself computing slope quite often, so let's just do some practice together to make sure that you know what you are doing. So I've given you 4 questions. I'm going to go through them with you, but if you are feeling confident, you should press pause and try the 4 questions before I go over them with you. So let's get started. For my first question, and for each question, again, I'm just using that same formula that says y2 minus y1 divided by x2 minus x1. So my second y is 1, my first y is 0, my second x is 3, my first x is negative 2. I'm going to use my keep, flip, change so that I don't mess up my signs. 1 minus 0 is 1, 3 plus 2 is 5. I have a slope of 1/5. So I can see, based on the graph of those 2 points, that I did in fact have a rise of 1 and a run of 5 to get from the first point to the next. For my second example, I have second y is 2 minus first y also 2. My second x is 2. My first y is negative 1. That gives me a numerator of 0, a denominator of 3. So the question is this horizontal or vertical? Remember, a slope of 0 is going to be horizontal. And as we can see, this is a rise of 0, a run of 3. A rise of 0, a run of 3. For my next example, I have the second y of negative 1 minus my first y of 4. My second x of 1 minus my first x of 0 gives me negative 5 over 1, which is just negative 5. So negative 5 is a fairly large negative number, so it's going to be steep, and it's going to be negative, which means pointing down from left to right. And I can see, based on this graph, that I did have a decrease of 5 to a run of positive 1. And finally, I have my second y of 1, my first y of 4, my second x of 3, my first x of 3, and I end up with negative 3 over 0. So this is an undefined slope. Remember, undefined is going to be a vertical line, and we can see that is what we have when we graph those points. Writing linear equations in two variables. We have practiced how to use slope and how to find slope if you are continuing on through this section video. If you are not, please go back and watch the other mini videos on how to do both of those things. But now we want to take a look at how to write a linear equation in two variables. So the first thing we're going to do is we're going to compute the slope. If they give us 2 points, we're going to just find the slope of the line using those 2 points using the slope formula. Then we're going to use point slope form by replacing m with the slope that we just computed and replacing x1 and y1 with values from one of the 2 points, and it doesn't matter which one. One thing I would point out to you here is be super careful, because as you notice, we already have a minus, so if you have a negative value, you're going to subtract a negative, and that's going to be positive. We're going to go from here and very easily use algebraic manipulation to get into our final product of y equals mx plus b. So let's take a look at an example together. We have 3 examples here, and you can choose to do any of them on your own. The first 2 we have already found the slope for, so they will look familiar to you. The third one is not familiar to you. Keep in mind we're going to be using the equations for slope, y2 minus y1 over x2 minus x1, and the point slope form, y minus y1 is equal to m times x minus x1. So let's take a look at the first one together. We'll start with the slope. Second y minus first y over second x minus first x. We get positive 1 over 5, which is the same 1/5 that we had previously. Now we're going to use point slope form, and you can use either point. So either negative 2, 0 or 3, 1. I'm going to use negative 2, 0. So y minus the y value of that point, and then my slope 1/5, x minus the x value of that point. On the left-hand side, y minus 0 is just y. On the right-hand side, first on the inside, I'm going to keep flip change to make that x plus 2, and then I'm simply going to distribute the 1/5. So 1/5 x, 1/5 times 2 is 2/5. And if I take a look at my graph, it does appear that the y-intercept is at 2/5, and if I go up 1 over 5 from there, that takes me to another point on the graph. Let's look at a second example. Again, start with slope, negative 1 minus 4, 1 minus 0. I end up with negative 5 over 1, or just negative 5. Using point slope form, I have y minus 4 is equal to negative 5, and then x minus 0. Again, I chose the first point, but you would get the same result if you chose the second point. On the left-hand side, I have y minus 4. On the right-hand side, negative 5x, and negative 5 times 0 is, of course, 0. So I'm simply going to add 4 to each side and end up with y is equal to negative 5x plus 4. So again, it does appear that our line goes through positive 4 and has a slope of down 5 to the right 1 to get to the next point. For our last example, this is one that we haven't looked at before. I wanted to give you one where the slope was given to you already. And really, those are great because that just means we get to take out that first step where we find slope. So think about it without having to do this step, and that just means less work. So I'm going to go straight to slope-intercept or to point slope form. Y minus the y value equals the slope that I didn't even have to compute, and x minus the x value. So I'm using the 0.11. So I get y minus 1 is equal to negative 2x, and negative 2 times negative 1 is positive 2. Then I'm going to add 1 to each side, and I end up with y is equal to negative 2x plus 3. So let's take a look. My graph does go through at positive 3. If I use the slope of down 2 to the right 1, down 2 to the right 1, I can see that those are additional points on my line. Parallel and perpendicular lines. We do want to talk about parallel and perpendicular lines and what that has to do with slope. So when you're dealing with two lines that are parallel to one another, parallel lines are going to have the exact same slope. Their slopes are going to be equal. So if I told you I had a slope of 7, and I said, what is the slope of a line parallel to that? You would say that it's 7. However, if I'm dealing with lines that are perpendicular, keep in mind perpendicular lines are lines that will cross one another at a 90-degree angle. If that is the case, we need their slopes to be opposite reciprocals. Opposite reciprocal means that I'm going to take my slope, so let's use that same example of 7, and I'm going to write it as 7 over 1 for a moment. And if I'm trying to write the opposite reciprocal, I think about flipping it over, so that would be 1 over 7, and changing the sign. So m2, the second slope, the perpendicular slope, would be negative 1/7. So let's do another example before we go into actually writing the full equation. So for our example, we have a line, we want the slope of the line parallel to y equals negative 2x plus 7, and the line perpendicular to that same line. So if I'm trying to find the slope of parallel, this slope, as we can see, is negative 2. So the slope of the line parallel would also be negative 2. But the slope of the line perpendicular is going to be taking negative 2, flipping it upside down, and changing the sign. So instead of negative, now it's positive. Instead of 2 over 1, it's now 1 over 2. So the perpendicular slope is 1/2. For a great practice, we're going to take a look at the line 2x minus 3y equals 6, already graphed for you on the graph. And we are going to find the equation of the line both parallel and perpendicular to that line at the point 2, 1. So again, we're looking at this point. So we can see what that's going to look like. If I have a line parallel to that, it's going to look somewhat like that if I was a better artist, which I'm not. And a line perpendicular is going to look something like this. So let's see what we can do mathematically to come up with those equations. We'll start with the original. And we need to know what's the slope of the original line. So the original is 2x minus 3y is equal to 6, not in slope-intercept form. If it was, that would be quite easy. But I'm going to go ahead and subtract 2x from each side. and I'm going to divide each side by -3. That's going to give me 2/3 x, and then plus 2. Oh, sorry, minus 2. So let's double check before we do a lot of work based on that. It does in fact go through at -2, and I have a rise of 2 to a run of 3 to get to the next point on my line. So I feel pretty good about the slope of 2/3. So the original has a slope of 2/3. So now if I want to do the line parallel, I'm going to say y minus, and again I'm using the point 2, 1, so I'm going to use the y value of 1. I'm going to take the slope of 2/3 because parallel lines have the same slope, and then x minus 2. That's going to give me y minus 1 is equal to 2/3 x minus 4/3, and then I'm going to add 1 to each side. And keep in mind, as I add 1 over here, I'm going to think about 1 as 3/3 because when I add, I want those denominators to be the same. So I'm going to have y equals 2/3 x, and I have a -4/3 and a positive 3/3, so that's minus 1/3. So this is the line parallel. So we're saying it's probably going to go through about right here at -1/3. So let's take a look. I'm not very good at estimating apparently, but yes, that is in fact at -1/3, and it has the exact same slope and goes through the point 2, 1. So let's take a look at the other example, the perpendicular line. And perpendicular line, instead of having a slope of 2/3, remember I'm going to flip it and change the sign. So I'm going to have a slope of -3/2. So y minus the y value of 1 is equal to my slope of -3/2 and x minus 2. On the left, y minus 1. On the right, -3/2 x. -3/2 times -2 is positive 3. Then I'm going to simply add 1 to each side. So y equals -3/2 x plus 4. Let's take a look and see how we did. It does in fact appear to go through at 4 and have a slope of down 3 to the right 2. So we're feeling pretty good about our efforts. Applications of slope. Let's talk about slope in real life. So in real life problems, the slope of a line is either going to be interpreted as a ratio or a rate. So if you're dealing with a numerator and denominator, or an x and y value that have the same units of measure, we're going to talk about that as a ratio. If you have an x and a y value that have a different unit of measure, then the slope is a rate or a rate of change. We're going to start by looking at a ratio example. So a steep grade sign is necessary whenever the grade of the roads is 7% or steeper. So how do I know this is a ratio? Because if it were a rate of change, we would have to talk about what the units of measure are. Because it's not saying that, it's saying 7%. Oh, let me switch colors there. We're saying 7%, that just means that it's a ratio. 7%, 7/100. That's how we can think about this particular example. We're on a road that rises 400 feet in 1 mile, which is 5,280 feet. The question is, should this road have a steep grade sign? So how am I going to do this? Well, one obvious way is I have 7/100, and I have 5,280 as what I'm comparing it to. I could try to solve for x and say, what's that number? But honestly, that's just a little more work than I want to do. So instead, let's just use the 7%, and let's say, okay, if I have 400 over 5,280, I can simply find that as a decimal, which is 0.0758 or 7.58%. So the question is answered quite easily. Should our road have a steep grade sign? Yes, it should, because it is greater than 7%. Let's take a look now at a rate example. We have the population of Nebraska in 2016 was about 1.906 million. In 2020, about 1.938 million. So we're going to use the information to write a linear equation that gives the population in millions in terms of the year. How are we going to do that? That's what a lot of my students do. They stop right here and they say, okay, if you give me two ordered pairs, I can find you the slope, I can write the equation, but don't put words in there or I don't know how to do it. So put it in terms you understand. In 2016, the population was 1.906 million. In 2020, the population was 1.938 million. Now, for simplicity, I'm going to say this is going to be the year, how many years since 2000, since the year 2000. So I'm going to change that to 16 and 20. And in terms of the year, I'm going to say since the year 2000. And you could do that for starting at 2010 or 2015, but make it easy, 16 and 20. Now you have two ordered pairs. Now I can use those ordered pairs to find the slope, just as we did before. I can use one of those two ordered pairs to use point slope form to come up with the equation of the line. So here's my equation. That's the first thing I'm asked to do, is to write a linear equation that gives the population in millions in terms of the year, and we're going to say since the year 2000. Then it says, now I want you to predict the population of Nebraska in 2024. So does X or Y represent the year? Well, obviously here we've used X to represent the year and Y to represent the population. So if they're telling me the population of Nebraska in 2024, I'm going to not plug in 2024, but I'm going to plug in X is 24. That's the years, 24 years since the year 2000. So I'm going to replace X with 24, and I'm simply going to do the algebra from there. Now, no story problem is complete without a conclusion, so my conclusion will be written in sentence form. The estimated population of Nebraska in 2024 was 1.97 million. Coming up next, we're going to take a look at functions.